Hello, everyone. Good afternoon. So it's 3 o'clock here in Portugal. We can wait a little bit more, just a little bit more, in more minutes for the rest of the people. But I think I can start by introducing myself. So my name is Anna. Oh, sorry. Okay. So yeah. So my name is Anna. I'm a physiotherapist, and I work for Sensing Future, which is a medical device company and is specialized in posturography devices. Um, I have a master degrees in human physiology, specifically in exercise physiology. I have worked in rugby with the rugby as a physiotherapist, and also at a clinical practice in neurology and orthopedics physiotherapy. And here in Facing Future, my job is focused on reading a lot and writing a lot. So I can help to develop our products in accordance to the latest scientific evidence, and also being the middle woman between the engineering and the clinical practice. So I want to thank you for being here and for taking interested in our webinar. So I think I can, yes, I think we can start now. Um, let us, okay. So today's webinar is going to be about balance disorders and the assessment of balance disorders within the within the neurologic disorders context, and we will explore some topics. So we're going to talk about balance control system and the sensory interactions between these systems, the balance control disturbances in neurology. So, how balance is affected within this context, how to assess balance using posturography, and I will try to explain some main parameters such as the center of pressure in this context. The role of posturography in the assessment of neurologic disorders, and we will also go through some assessment protocols, um, balance assessment protocols that can be used for balance assessment in neurologic disorders. So, limits of stability, the Romberg test, and the sit-to-stand protocol. So this is going to be the first part of a two-part webinar series. The next webinar will be about interpreting the results of the assessment and creating an intervention with the exercises we have on our software. So I hope you find it useful above all. And I know this is a lot of information, so the balance disorders is a very complex subject, and even posturography is also a very wide world. So if you want to, I wanted to ask you to write down your questions, sorry, or your notes. So if you want to, you can book a meeting with me to discuss these questions and to give us feedbacks and to give us ideas for the next webinars. You can just scan this QR code, okay, and you will book a short meeting minutes, 15 minutes meeting with me, okay? So this QR code is going to appear sometimes during the presentation in specific spots where I think that there's a lot of information, or there are studies, research studies shown on the slides, and for that reason, you can you will have the opportunity to scan the QR code through the presentation. Okay, so I think we can move on to start. Okay, so let us start by contextualizing neurologic disorders and how they impact balance. So we know that neurologic disorders are one of the major causes of mortality and disability worldwide, and they are associated to varying degrees of sensory and motor problems. So inevitably, there will be balance control impairments that most times are associated with an increased fall risk, limit activity capacity, that of course it will restrict participation in daily life situations that ultimately leads to social isolation and physical inactivity. Um, this has a very high impact um, in the quality of life of these people, and so it's a snowball. Um, we know that having a balance control is required for maintaining postural stability and for enabling safe mobility related daily life activities that include weight shifting and changing positions while we perform manual tasks. So while we walk, climb stairs, go through obstacles. Without balance, our interaction with the world would be highly compromised. So let's move to the balance control system. So how does it work? And we know it's a very complex system because it depends on other systems. So it's some people say it's a sixth sense. So we know that it's not a very easy task to understand. It's complex, but it's vital sense that we have. So without balance, we could not even get orientated in the world. We could not get we could not stabilize our vision while moving, and even our cognition would be affected. So, but how does it work? So we know that the balance control is achieved through the interaction and integration of several sensory systems. We have the visual system and the vestibular system that control and make possible to stabilize our gaze, and interconnected with the somatosensory system and our motor system, we can achieve postural orientation and postural stabilization. So it's this interconnection between systems that makes it possible for us to see while we are moving, to adapt and to adjust to different environmental contexts. And so all this information is processed in the central nervous system. So an adequate motor response is produced to promote the right movement pattern. And we know that this mechanism of processing and integrating of sensory cues of body motion produces an error signal between predicted and actual sensory cues of movement that will compensate for these errors. So this means that our brain is making real-time posture adjustments while we move, or even to catch us when we fall. So this is an ongoing loop, as you can see here, just for maintaining balance, just for walking, for standing up and walking through the door. So very interesting. So as I already said a lot, it's a very complex mechanism and a very complex neural network, as you can see in this graph. So our balance system must have the ability to orientate our body in relation to the gravitational vertical using the vestibular system, and to be aware of our body position and movement in space using the visual, the vestibular, and the somatosensory systems. So the integration and organization of these sensory inputs is done by the central nervous system, including the cerebral cortex. Someone has the mic on? Sorry. Yeah. Because I'm hearing myself. Pedro, I think it's you. I was saying that this integration and organization of sensory inputs is made to the central nervous system by the cerebellum, by the cortex, the brainstem, also known as the powerhouse of postural control. So, in order to maintain balance, sensory inputs from all these systems are used as compensatory mechanisms. So these compensatory mechanisms allow us to rapidly reweight inputs in relation to changes in environmental conditions, or even in the presence of some injury or pathology. So in a situation where a healthy person is standing on a firm surface in a well-lit room, we depend approximately, the weight of each system is 70% on the somatosensory input, 20% for the vestibular input, and 10% for the visual input. So if the conditions change, for example, if we now are in the dark room, what will happen, and it is needed for us to maintain our postural control. So what will happen is that the weight on the visual system will decrease, and the weight of the vestibular and somatosensory inputs weight have to increase. Okay. Even the same happens if we walk in an uneven surface, for example, sand. For us to be balanced while walking on sand, our central nervous system has to decrease the weight, the reliance on the somatosensory input, and increase vestibular and visual weight of these inputs. So this is important because it allows us to predict context-specific instability. So, in which an individual is at risk of falling or losing balance. For example, a person with impaired proprioception, so for a polyneuropathy or some kind of disease, will show higher reliance in the visual system. So we know that when this person walks at night, or when this person is subjected to a conflicted, when this person walks at night, this person will have difficulties to maintain balance, because this person doesn't have the integration of the somatosensory system. Now the visual input is also decreased, and so she will have problems balancing. And so we can try to think about strategies to prevent any accidents. For example, walking with a cane at night, or even for our rehabilitation process. This is important. So, for example, another example of a person with a vestibular loss. will rely a lot in the visual system and in the somatosensory system. We know that if we subject this person to a conflicted image, this person will have some difficulties understanding what is happening, if there's movement, if there's not movement. So it's important to understand that this mechanism is essential for balance control, and when we are in presence of some pathology or even just some changes in environmental, we need to rapidly reweight the weights of each input. Okay, so we know that for a healthy individual, balancing is a simple task that requires little effort and energy. So the innate difficulties associated with balance are not disclosed until something happens, or an injury or a pathology impairs its control. So we know that within neurologic disorders, it is possible to observe serious alterations in terms of the peripheral and central nervous system, such as changes, alterations in proprioception, some changes in the afferent pathways, changes or injuries that compromise the central integration and organization of sensory input, or changes or injuries on the afferent pathways, even the musculoskeletal system. If it's affected, of course, we're going to have a balance problem. So there's a lot of places where something can happen that will impair balance. And within neurologic disorders, it's frequent, very frequent to have this kind of impairment. Okay, so before we go into balance assessment with posturography, I think it's important to talk a little bit about some common neurologic dysfunctions and how balance is compromised in which one of them. So let's start with stroke. So we know that stroke patients frequently show impaired balance, mainly due to changes in proprioception. Muscle tonus, we can have increased spastic or decreased muscle tonus, and it's of course very important for motor control, for the quality of movement, muscle strength, reflexes, so neuromuscular reflexes, and motor control. So what we see in a stroke patient is normally they show increased body sway. So during a quiet stance, they show a symmetrical lower limb weight distribution, decreased limits of stability. That is something that we are going to talk later. They will have excessive reliance on the visual input. So this is in accordance to what I said before. So because they have most of the time the proprioception is compromised, they depend a lot on vision, and this is something that we can test on our clinical practice. And also they will show and have some impaired anticipatory postural adjustments. Okay, so I have some studies here. That's why here you can again see the QR code. So I will show you some research articles, just a few, of course. I have a lot on my library right now. So if you want and are curious about any of them, or you want more, again, please scan the QR code to talk with me so I can see what I have and how can I help you, okay? So let's move on to Parkinson's disease. So in Parkinson's disease, there is common to have, of course, proprioception, also dysfunction, changes in the axial muscle tone and loss of postural reflexes, impaired cognition, changes in visual stimuli perception, and a narrow stance. So we have here several factors that will have an impact, a brutal impact on balance control. So we have system, the somatosensory system that is affected. So we have impaired cognition, which is also associated with the integration and coordination of the inputs, changes, alterations in the perception, the visual stimulus perception, and now also we have a narrow stance. So a narrow stance makes it more difficult. So what we see is that patients, Parkinson's disease patients, show a displacement of the center of mass over the base of support, increased body sway, so they sway more and they sway faster. So they have difficulties in making in controlling the swaying. Okay. You have some studies also. For concussions, okay, concussions. So concussions are acquired, so acute neurologic disorders that can also lead to balance dysfunction, and is one of the major problems that can arise. So we have symptoms like dizziness and steadiness or imbalance, and those symptoms have most frequently been attributed to sensory organization problems involving the use of the sensory systems. More on the is the integration and organization. So what happens is they most of the times have difficulties to resolving conflicts. For example, walking on unstable surfaces, or the absence or inaccurate of information provided by the visual system, they will have difficulties resolving these sensory conflicts. So and in addition, the vestibular system is often affected as well. So what we see is that people who suffer concussions normally also, besides dizziness and unsteadiness, also have decreases in the limits of stability, which I will also explain later. So, and finally, multiple sclerosis, which is a disease that unfortunately, as physiotherapists, as doctors, we come across often. So multiple sclerosis, chronic diseases of the central nervous system that affects the brainstem, the spinal cord, and the optic nerves. So the main symptoms of multiple sclerosis are weakness, spasticity, so a pathological increase of the muscle tone, which will affect movement quality a lot, fatigue, proprioceptive deficit, coordination deficits, vision alterations, and cognitive alterations. So here again, it's very likely that a person that has all of these symptoms will have postural imbalance, problems in gait, and a higher fall risk. So we have the somatosensory system compromised. We have vision alterations. We have alterations in the muscle tone, so quality of movement, neuromuscular reflexes, and cognitive alterations. So, of course, it's drastic. Okay, so let's move on to the balance assessment. So, interestingly, many patients are not fully aware of changes in balance and in posture, which is frequently one of the earliest signs of a neurologic disorder. So this emphasizes the importance of rigorous and objective balance and posture assessment as part of the clinical examination. So the aim of the clinical and the aim of balance assessment as part of the clinical examination is to firstly understand if there is in fact a problem, and then to understand the underlying causes. So we want to have objective and quantitative measurements that can be translated into simple but vital information for diagnosis and treatment planning. Okay? And so we have several ways of assessing balance. We have clinical tests and scales that are validated and widely used in clinical practice. They require very little material, and they are very easy and fast to perform, and they depend on the clinician's own observation and analysis. Okay, but we can also assess balance in an objective way, and here's where posturography comes to play. So posturography is a way of assessing balance it's a non-invasive technique that quantifies an individual balance behavior in the upright stance. It can be done statically and dynamically. So statically without any external disturbances, or dynamically during specific movements, voluntary movements, or using dynamic platforms. Okay, so posturography is seen as the golden standard for postural assessment, postural control assessment. The most common measure used in posturography is the center of pressure. And what is the center of pressure? The center of pressure is the location of the point of application of the ground reaction force on the support surface. So this ground reaction force corresponds to the sum of all acting forces on the plantar surface and represents all the muscle and gravitational forces acting on a period of time. So using technology like force plates and pressure plates, it is possible to quantify small corrections that are performed to oppose the destabilization effects of gravity, also known as body sway. Okay. And so this stabilization of the body is visible in the center of pressure displacement. You can see them. You can see this here on these stabulograms. You can see the center of pressure displacement in the medial lateral and the anteroposterior directions, and you can assess this displacement, to measure this displacement during a period of time. Okay. So the center of pressure is like the projection of our center of mass on the floor. So in this picture, it's easier to see, to understand, and so it is a point that the projection point of the center of gravity of the body. Okay, and it moves because we are always swaying on some different directions, and we can measure this displacement. Okay, so this means that our body can be translated into center of pressure values. Okay, and if we measure COP displacement, this is also another way of analyzing the displacement. This is a statokinesiogram. You can see the displacement of the center of pressure are these little points, and the gray line is the total displacement that the COP made during the test time. So if we have a way of measuring distance and displacement and during a period of time, then we can calculate velocity. And so the mean COP, center of pressure, velocity, which is the distance traveled by the center of pressure, okay, divided by time, is the velocity formula. It's a very used parameter for assessing postural control, so in clinical, and it's also a very frequent parameter in research. So you will find a lot of studies that talk about the mean COP velocity. So we know that the higher the velocity, the worse the postural control is. So the person is swaying with a lot of velocity, is not able to control his or her body, try to control and contradict the instabilities forces. Okay, so besides the velocity, we also have also have a lot of parameters and other metrics that are calculated through the center of pressure displacement. There's really a lot of them. I am just going to show you the ones that have more utility for clinical assessment and are found also in research. So again, the COP displacement or length, which is a total length the total length of the center of pressure pass. So what the amount of length, so the number of points that the center of pressure goes along the plate, and this is calculated by the software. We can also have measurements in only one plane or another. So this is also important if you want to see if there is more sway in, for example, in the medial lateral plane or on the anteroposterior plane. And this is the same. The interpretation is similar to the velocity. The higher the center of pressure displacement, the more unstable a person is. We also have the range, which is the difference between the maximum and the minimum COP values, and a very important parameter, which is the center of pressure ellipse area. This is also a very, very useful parameter for clinical assessment and also for research. So this area contains around 95% of the points of the center of pressure, which means that the larger the area, the more unstable a person is. So it's very visible, it's very easy to understand. And also another parameter that is not here, but I will explain you, and it's related to the ellipse area, which is very, very important, is the rotation angle of this ellipse. So the rotational angle of the ellipse will give us a predominant direction of sway. So for example, to understand if the person is swaying a lot more, more in the anteroposterior direction or on the medial lateral, and more to the left or more to the right, we can have that information, and for a balance assessment and for treatment planning is very useful. Okay, and so using posturography for balance assessment allow us to quantify balance behavior. So while performing specific clinical tests, protocols like the Romberg, the MCT-SIB, the C2 stand, the limits of stability, among others. So this means that we can assess different sensory systems involved in balance. So we can understand how is this compensatory mechanism working, if we can subject the patient to different sensory environments. We can assess and see changes of automatic and voluntary motor responses to assess postural strategies, deviations from the center of gravity, so asymmetry of stance, and also changes on the limits of stability. So what we have is we end up with an objective functional assessment of balance. And the benefits we have with this is that we now have an objective data, which allow us to have an objective and a rigorous baseline setting. So we can assess the progress of the patient, to evaluate the results of our intervention. We can make clinical decisions easier. We can compare normative our data against normative data, and it makes it easier to identify functional deficits. So this is the main benefits. And so what we have is we have two types of assessments, balance assessments. We can either evaluate and assess the sensory input or the motor output. If we evaluate sensory input, so we are talking about static evaluation, and we have a lot of protocols. So we have the MCT-SIB, the balance error scoring system, which is more used for concussions, the Romberg test, the unilateral stance, among others. And for the motor output assessment, we will have the dynamic tests. So we have, for example, the limits of stability, the rhythmic weight shift, and the sit to stand. Okay. And so let us just very quickly, I wanted to show you some studies that used posturography for assessing balance in specific neurologic disorders. Okay, so the first one that you have here is very interesting. Is a study that was conducted in 2020 that showed that balance alterations in multiple sclerosis patients could be detected with static posturography before being perceivable by the physician. Okay. Both the ellipse area and the average sway speed could sense differences between healthy subjects and multiple sclerosis patients with normal cerebellum function and normal Romberg tests. So it's a very interesting study. Again, if you want to read these studies and you want more, scan that QR code. Okay, now in stroke patients, chronic stroke patients. So the first study aimed to assess correlations between time up and go and functional reach test to center of pressure movement performed during 4 conditions. So during sit to stance, during standing with open eyes and closed eyes, and during the functional reach test. They concluded that the center of pressure parameters were significant predictors of functional test scores. Okay, so specifically, the velocity of the center of pressure was mostly higher for the individuals with stroke compared to healthy individuals during standing and with eyes open and eyes closed and during sit to stand. And I also have here another study with stroke. So this second study aimed to investigate the relationship between the center of pressure position and sway and changes in gait variables in stroke patients. Yes, so they measure the mean COP position, the ellipse area, that parameter that I showed you, and the COP total displacement. So another parameter that I showed you. So all parameters were measured during 2 test conditions with a force plate, with eyes open and eyes closed. So their data showed a negative association between the center of pressure position in the mediolateral plane, so an asymmetric stance on the mediolateral, and gait and velocity, gait position and gait velocity and cadence. So for Parkinson's disease, I also have 2 studies. So the first year aimed to investigate the utility of the quantitative posturographic parameters in balance assessment in Parkinson's disease, and this part is important, not complaining of balance dysfunction. So the authors concluded that Parkinson's disease patients not complaining of balance dysfunction showed a higher mediolateral sway, and that posturographic parameters show high sensitivity for detecting balance dysfunction, even in absence of clinical signs. Okay, the second one, and the last one for Parkinson's. The authors aim to assess test-retest reliability of 4 parameters of center of pressure in individuals with Parkinson's disease in different positions and while performing manual tasks. So the study results show that the COP-based measurement of balance are reliable in Parkinson's disease, especially the Romberg test condition with eyes closed. Okay, the ellipse area and the COP mean velocity were the most reliable variables for Parkinson's disease. So ellipse area and COP mean velocity. So we have the COP displacement, the ellipse area, and the COP mean velocity, so the sway velocity. These 3 parameters are the most important for clinical assessment. And even for, in research, you find them a lot. But for clinical assessment, when we want to have a simple way of assessing, and we don't want to take a long time reading or interpreting parameters. These ones are easy to interpret, and they are studied and they are validated in a lot of disease, balance disorders, and in neurologic disorders, they always appear in the literature. Okay, so no more studies now. I just wanted to show you a small sample from the scientific literature we already have that aims to investigate the role of posturography for balance assessment in neurologic disorders. So our PhysioSensing software has 14 assessment protocols that measure balance through COP displacement. Okay, it's not below. So in front of you on the slide, you can see our evidence-based recommendation for which protocol is more adequate for assessing specific balance dimensions. So we have, for example, for sensory reception and organization, the MCTSIB, the Romberg test, and the Total Balance Pro. For proprioception assessment, we can use the limits of stability, the Romberg test, the MCTSIB, and the Total Balance Pro. For motor control, again, the limits of stability is one of my favorites. The rhythmic weight shift and the Total Balance Pro and the sit to stand. For muscle strength, we can use the weight-bearing squat, sit to stand, limits of stability, and Total Balance Pro. For reflexes and reaction time, again, limits of stability, rhythmic weight shift, sit to stand, and Total Balance Pro. Posture control, we have our protocol body sway that gives you more than 30 COP-related parameters. So it's a very, very complete posturographic analysis. I'm not going to say it's not good, but it's good for research, and for clinic we need less parameters and a more simple way to assess balance and body sway. It shows too much. For weight distribution, you have sit to stand, the weight bearing squat, and for a functional analysis we use the sit to stand. Okay, so again here, if you have any questions, please write them down, and if you want, you can scan out the QR code and book a short meeting with me, so I can help you or take to understand or to help you understand the protocols, or if you want to discuss anything, give me feedback, whatever. You just scan the QR code, and I would be very happy to meet you. Okay. Okay. So moving on. Let us create a fictional patient. Okay. A patient with a neurologic disorder, not specific, whom we need to assess balance. And this is the main goal for this webinar and the next one. So to show you how you can use the protocols to assess and treat balance dysfunction in a neurologic patient. So to keep it simple, let's just say that we want to assess proprioception, motor control, and have a function measurement. So we're going to choose the Romberg test, the limits of stability, and the sit to stand. Okay. So let's start with the limits of stability, which is, I think, is my favorite. So the limits of stability is a concept defined as the point at which the center of gravity approaches the limits of the base of support. So in other words, represents the maximum distance that an individual can displace its center of pressure without losing balance. So the typical range is 8 degrees front, 8 degrees to the sides, and 4 degrees back. And this stable area represents the cone of stability. So it's referred as the cone of stability. So a stable area. And our central nervous system has an internal representation of this area, of this cone of stability, that it uses to determine how to move to maintain balance. So in many elderly people with balance disorders, this cone of stability is often very small, or the central neurorepresentation of this cone stability is distorted. So both of which affect their selection of movement strategies to maintain balance. So we know that subjects predisposed to falls tend to have small limits of stability. And for example, in basal ganglia disorders, such as Parkinson's disease, it can also result in an abnormal representation of this area, so leading to more postural instability. Okay. So limits of stability is a common protocol used for evaluating stability and voluntary motor control in dynamic states. So this protocol provides valuable biomechanic information by tracking the instantaneous changes in the center of mass, velocity, and position. And then it can be used, and it's used a lot for screening, assessing fall risk, particularly in elderly populations when there is already a cognitive and attention deficit, which will also have a really big impact on the limits of stability. Okay, so what are the possible causes for limits of stability impairment? There's a lot. So first of all, impaired cognition, attention and focus compromised, common in aging. Also, a campaign with this possible distorted representation of the cone of stability. We know that the fall risk increases a lot with impaired cognitive. It's very important. And we can understand, or we can have well, this will be discussed on the second webinar, but this protocol gives us a lot of parameters, okay, and some of them we can take out some information that will give us hints on these specific points. So, of course, neurological impairments, changes in muscle tone, muscle control, movement velocity, things that are very frequently in a lot of disease, such as Parkinson's disease, of course, will decrease the limits of stability. Musculoskeletal impairments, so weakness. So muscle weakness, mostly the posterior muscle change, so the plantar flexors, they have to hold the body in an unstable position when the person leans to the front. Limit range of motion, so the movement starts in the ankle joint. So if we have limit range of motion or rigidity, this is, of course, is going to impact limits of stability. the presence of pain. We know that pain affects neuromuscular activity. So I've seen a study with lower back pain and limits of stability. So we know that the presence of pain affects this, can affect limits of stability, and of course injuries in the lower limbs. So this protocol can also be used for sports orthopedics, because we can assess asymmetry of movement in every direction, from, for example, left direction and right direction. You see in the top corner, the right corner, there is this drawing represents the center of pressure excursion in the 8 directions that are part of the protocol. So the person is in the middle and he has to lean to achieve these 8 targets, and these lines are the center of pressure excursion. So if you want to assess balance with this protocol in a person that has is recovering from a lower limb injury, you will clearly see an asymmetry of movement and control, motor control in those in the different directions. Then, okay, moving on. So emotional overlay. Overlay. So we have fear and anxiety. It's normal, and this happens a lot in elderly people. So, and you can understand when this is happening when you're analyzing the parameters. You have the reaction time, and this reaction time is always slow, but all other parameters are good. So this person is afraid and caution with movement, and is also something that we need to address and treat. And of course, imbalance due to vestibular causes. Okay, so the Romberg test. So we are going to assess this patient with the limits of stability, the Romberg test, and the sit to stand protocol. And today I'm just going to explain you a little bit of what is the goal associated with each protocol, but the results of the assessment will be discussed on the next webinar. Okay, so the Romberg test, it's a very famous test. Is a neurological assessment that is used by healthcare professionals worldwide. It assesses the function of the dorsal column of the spinal cord, so proprioceptive function, and it's been used in clinic for 150 years, a lot of time. So the test is positive if the patient loses balance with their eyes closed. So they maintain balance with eyes open, but then they close their eyes and they lose balance. And this means an increased body sway, placing one foot in the direction of the sway, or losing balance, so falling. This suggests a proprioceptive dysfunction. Okay, in PhysioSensing, in our software, we have 2 more conditions that are performed with unstable surface, so a balance, and that what it does, it decreases the somatosensory input, so the proprioceptive input, and increases the weight of the visual and the vestibular sensory systems. You can assess the interaction of these 2, and in the last condition, when the person is standing on top of the foam, standing on top of the unstable surface with eyes closed, we are assessing mainly the vestibular function. Okay, and then we will have a lot of parameters to go through on the next webinar. Okay, and finally the sit to stand protocol, which I really like, because let's face it, like it's a function movement, the movement of changing position from a seated to standing, and we do it every day. there's a lot of studies with the sit to stand balance protocol. So as you can see in the pictures, the plate is placed in front of the chair, and when the command get up appears on the screen and a beep signal goes off, the patient has to stand up as quickly as possible without using his arms. So here I think my colleague Andre is using his arms, so he's doing it incorrectly. And so the software will measure the center of pressure displacement during the entire movement and other related metrics, such as the weight bearing symmetry between the two legs. This is a very good protocol for neurology because you can see when someone is not putting weights or is as a big asymmetry between lower limbs during movement. Okay, so we will look into the results on our second webinar. Yes, so we really had to divide this webinar in two parts. It was very long and tiring for you and for me, but for you because there's a lot of information. And so in the next webinar, we are going to show you the results of these assessments. Okay, this is a fictional patient. So it's fictional results, but we will show you the results and we will interpret these results together, and then we will I will show you how to create a rehabilitation section with exercises from our protocol and how to change the parameters from each exercise to fit our patient's needs. Okay, so the next webinar will be next Tuesday on the 28th of November. So I think you will receive an email for signing up. Please do. And on behalf of Sensing Future, I want you to thank you. Really, thank you so much for being here. I want to say sorry for my English because sometimes I'm thinking in Portuguese and it's difficult. I hope you like it. I hope you find it useful. Here again, you have the QR code where you can scan and you can talk and discuss with me. We would be very, very happy to hear your feedbacks and ideas for upcoming webinars. And if you already have a PhysioSensing plate and you are already working with a PhysioSensing and you want to discuss cases that you have or to ask anything or ask for research, please talk to me. I have had the pleasure to talk to a lot of people so far, and I have learned a lot with everyone, and I'm really happy if I can help. Okay, so and for people that are interested in knowing more about our solutions, our platforms and our softwares, again, you can scan the QR code and book a meeting with me. Okay, so for additional info, you can also visit our site and our blog. Okay, in our blog we already have some small articles that are easy to read, like 5 minutes, 4 minutes, 6 minutes reading material about posturography, about some protocols. So maybe they can help you if you have any specific questions. Maybe the answer is in these articles. We also have infographic and an ebook available. I think most of you already received emails with this content, but if you haven't, please send us an email. You also have my email here. You can take notes and send me an email. Okay, so thank you very much for your attendance, and please give us feedbacks, and we'll be happy to hear from you. Okay, thank you.